In this video, I'm going to show you guys how you guys can build a very smart AI agent that's capable of reasoning over any data you give it, answering questions over it, retrieving context, answering, context specific questions. Pretty much, an agent that's able to do anything with the data that you provided. So for this video, we're going to be using a National Missile Defense PDF. This is a 54-page PDF that describes, weapons, some of the best weapons the United States has, defense systems we have, foreign policy with Russia, the Cold War, all that kind of stuff. How we kind of deal with weapons policy, all that kind of, complex topics that, we have embedded in this 54-page document. So let's jump right in. So first, how we're going to model our AI engine is a router engine. So we're going to have a router that, goes to QA query engine as well as a summary query engine. So for example, if you imagine question and answer queries, it's like, what are some of our best weapons? And a summary query engine is like summarize the Cold War. These two types of queries are really different. They have different types of information that, the agent needs to store and return. It also gives our agent more power to, answer these questions better. And how we're going to kind of model this is we're going to have a router that goes to, a summary index, a vector index. It chooses, which kind of route that we want to take over our documents. And this outputs the best, most relevant answer for our queries. So I've already pre-ran my document here, but this is the exact code I've used. You guys can reference this, also the times that it runs for. So first, what we're gonna do, we're gonna import OpenAI, and we're gonna copy and paste the OpenAI's API key that you guys get from the console, the dashboard. And then we're gonna import nestasync.io, apply it. You guys don't have to know much about what this does, but this just applies kind of semantics, synchronization across our whole file because we have a constant loop running in the background of our notebook. This is just more so of a semantics thing. Now we're going to use LlamaIndex. LlamaIndex is a very popular and powerful library framework that has many different modules, embedding models, things like that, that allow us to, read our data, build complex agents over it, embeddings over it. It's a very good tool that you should have in your tool belt, and I'm going to implement it in this video, show you guys how you can really use it to build powerful agents. So what we have now is we're going to pass in our input file to the simple directory reader from LlamaIndex. This is going to load our data, load our documents. Now we're going to embed our model, embed our data. We're going to split our 55-page document, all the words in it, into chunk sizes of 1024. These are character-based chunk sizes. We're going to pass this into a splitter variable, which is going to split our entire document we passed here into the 1024 size chunks. And we're going to pass this, we're going to model each chunk as a node and store it in this nodes variable. Now what we're going to do is we're going to import all of our kind of dependencies here. We're going to import the OpenAI embeddings, OpenAI and settings. We're going to set our LLM to GPT 3.5 Turbo. You guys can try GPT 4.0 or, any even other models like Grok, Anthropic's models, things like that. But for this example, this embedding model and our LLM work perfectly well. Now what we're going to do is we're going to import our summary index and our vector store index. These are directly from our router engine. So what these do is these are going to allow us to pass in our nodes variable from earlier, and it's going to allow us to embed our data either as a summary index or a vector index, in this case both. And what we're going to do is we're going to define our query engine, the summary query engine as well as the vector query engine. This shouldn't take that long. It just kind of defines what we have as tools, allows us to define what we have as tools later on for our engine to better choose, which ones we want. So, we're going to provide descriptions for our context-based tool and our summary tool. This basically allows us here when we define a router query engine to pass in both of these tools, but our AI agent's also going to be able to choose which tools it wants to pick when it's answering specific questions from a user. So as I said earlier, like, if a user is like, what is weapon X? We don't need to retrieve a lot of context from that. We can just answer that through a summary tool, compared to a Q&A tool, which would be like, describe specific policies during the Cold War or something like that. So now what we're going to do is we're going to, you guys can run this just to test it out, summarize a document, and we're going to get a big summary of what this document does. It, discusses the challenges with the NMD and the useful U.S. nuclear weapons policy, all of this stuff. It's going to summarize it pretty deeply, and it's going to use our, we have verbose set to true, so it describes, our reasoning of our AI agent. This selects our summary engine because it's useful to, summarization-based questions, as you can see. And then this, tells us how many source nodes we used for it. So, we defined a lot of different, nodes and chunks for it. And, this query used 54 source nodes to answer this question, those, 1024 chunks we had. So now, we're going to ask it a Q&A type of question, which would choose the second, context-based query engine. So how did we navigate policy in the Cold War? And it's going to answer, it started with competitive policies, remained also, we wanted to commit to cooperative policies, all this different stuff, how China was involved. It's going to summarize that in a very context-based answer. And for this, we only use 2 source nodes because, this is more embedded in a tightly packed section in the document compared to this, which is, using way more source nodes to answer a summary-based question. So now what we're going to do is we're going to bring everything down into a one router query engine implementation. So what we have is our LLM model, the 3.5 turbos, same textual embeddings as before. We're going to load in our data, split it, all the same things as we had before, but we're just kind of defining this as one tool. And now what this will allow us to do is, instead of kind of doing this all separate, fragmented out, we have all of this in one kind of block. So now you guys can pass in any PDF you guys want here. Once you have this defined, you guys can pass in the defense PDF we have, or even any of your PDFs for your business, for your school, any types of PDFs you guys have. It'll do the same kind of function where it'll answer questions, go through the context, summarize anything you guys want. And we have our example here. What are our best weapons? And then it, outputs ICBMs are the best weapons that we can use. They're a good, deterrence to missiles. They help maintain tight control. So we have this kind of cool vector query engine that's able to, route questions into summary query engines, Q&A query engines, route it into specific, vector indexes or summary indexes, and use our custom documents here to answer these very hyper-specific questions that, if you want, you don't have to read the full 54-page document to, receive answers to specific good questions that, you want answers to for the time being. Thank you guys for sticking to the end. If you guys have any questions for how, this works, specific questions about LlamaIndex, or if you guys want tutorials about that, leave that in the comments. Over the next few videos, I'm going to be posting how we can use multiple PDFs, not just one defense PDF, but let's say multiple kind of army PDFs, defense PDFs, as well as how we can use tool calling in our agents to basically give our agents tools that they can call more than just the summary and the QA engine to, make decisions and do cool things over our documents and data. Thank you guys for watching. I'll see you guys next time.